Here we want to graph the circle x squared plus y squared plus 6x minus 4y equals 3. The problem is that looks nothing like the equation of a circle. The equation of a circle in standard form is x minus h squared plus y minus k squared equals r squared. So we have a little bit of work to do to get it to that standard form so we can identify our center and our radius. Here's what we do. You may recognize this. This method is called completing the square, right? And we do this twice. So I'm going to rewrite this. I have x squared plus 6x, and then I leave some space. Okay, plus y squared minus 4y, and then I leave some space, equals 3. Okay, so I've rearranged it so the x's are together and the y's are together. Now you take your linear term here, we could also call this the b term, the term that goes with just the single variable x. Take that, divide by 2, and square it. Okay, so divided by 2 is 3, squared is 9. Okay, then we're going to add that to both sides, plus 9 here, and to keep it even, we'll do plus 9 on the other side. Alright, same thing with our y term. We take the linear term, or the b term, the term that goes with the single y here, 4. Doesn't matter if you include the negative or not, because we're going to square it anyway. Divide by 2 and square it. 4 divided by 2 is 2, squared is 4. Okay, and then same thing, we add that to both sides. Okay, so now on the right hand side, I'll go down here with it, we have 3 plus 9 plus 4 is 16. On the left, we can complete these squares here. Well, we have completed the square. What we have is two perfect square trinomials. So this one, the first one is x plus 3 squared. Alright, the second one is y minus 2 squared equals 16. And there is our standard form. So you may need to go back and review a little bit on completing the square if you haven't done it in a while. That should be a method that you're familiar with from solving quadratic equations, somewhere in there. From here we can identify the center. The center is, in this case, -3, 2. -3, comma 2. We change the sign on both these terms inside the parentheses here. And then our radius is then the square root of 16, since this here is r squared. The radius is simply 4 in this case. Now we're ready to graph, so we just do our center, 3 to the left and 2 up. Let's see, right there. And then we'll go up 4, 4 to the left, 1, 2, 3, 4, 4 down, 1, 2, 3, 4, and 4 to the right, 1, 2, 3, 4. And then we connect those outer dots to make our circle. Alright, there is our circle of radius 4. Let's try another one. Here we have x squared plus y squared plus 6x plus 10y minus 2 equals 0. First thing we do with these is get this constant term to the other side. So I'm going to add plus 2 to both sides and rearrange. Okay, so now we have x squared plus 6x. Remember to leave some space. Y squared plus 10y. Again, we leave some space, and this is a plus y squared, by the way, equals, and now we have a 2 on the right hand side. Alright, same idea. Take your b term, divided by 2. That's 3. Square that, result, 9. Plus 9, plus 9. It's not always 9. Okay. On to the y's. Take that linear term, 10, divided by 2. 5. Square that result, 5 squared, 25, add it to both sides. Plus 25, plus 25. Okay, let's clean it up a little bit. We've completed the squares, now we have perfect square trinomials. So x plus 3, quantity squared, plus y plus 5, quantity squared, equals 36. Now we are in standard form. for a circle so we can identify our center, -3, -5. All right, I just changed the sign on both these terms inside the parentheses, and remember we do x first and then y for our ordered pair. Then for the radius we have r squared is 36, so the radius in this case is simply 6, the square root of that. Okay, now we're ready to graph this thing. So we have a center at -3, -5. All right, and then we just go 6 in each direction. 1, 2, 3, 4, 5, 6. 6 up. 6 to the left. And 6 down. Actually put us down here at -11. And connect those to finish off our circle. You get the idea? Hopefully you are a better artist than I am. Let's try another one. Here we have x squared plus y squared minus 8y plus 5 equals 0. Okay, so this one's a little different because we don't have any linear x term. We don't have any term with just an x. We have our x squared, but we're missing all the other x terms, and that's okay. So let's just rewrite this a little bit. X squared plus y squared minus 8y. I'm going to move that 5 to the other side by subtracting 5 from both sides. So that gives us -5 over here. And notice how I left some space here. Alright, I take my 8, divide by 2, and square that result. 8 divided by 2 is 4, squared is 16. Add 16 to both sides. Okay, so this gives us x squared plus y minus 4 squared. That's our perfect square trinomial, equals 11. So this is now in standard form, even though it may not completely look like it. Let's see. I mean, we could, if we wanted to, we could think of this as x minus 0 squared. So the x coordinate of our center is 0 in this case, and then the y coordinate is 4. Remember to change the sign on that there. Radius, all right, well, 11 is r squared, so the radius then must be square root of 11. We need to know what square root of 11 is in order to be able to graph this, so we feed it into a calculator and get an approximate value, about 3.32. That should be enough to graph it. We're kind of at a loss when we have these radicals to get an exact graph. But here we go. Okay, center 0, 4. Okay, so up here. And then we'll go about 3 1/3 in each direction. So 1, 2, 3, and then I'm just going to go another third of that grid line there. 1, 2, 3, and then another third up. That's the best we can do is estimate it. 1, 2, 3 to the left, and another third on top of that. And then 3 down and another third. Okay, something like that. Connect our dots, gives us our circle. Again, hopefully you have a steadier hand than I do. There we go. Mine always come out a little lopsided. I don't know what's up with that, but it's okay. We know that it's essentially a circle. So you'll eventually use this method for other conic sections, right? This completing the square method can be used to graph ellipses, hyperbolas, parabolas. It's a very useful method, so I recommend really spending some time to practice it because it pays off the better you get it down now.